Hey everyone, welcome. We hear about the magic of AI basically every single day, right? From self-driving cars to chatbots that can write poetry. But what if I told you that most of this so-called magic is powered by one surprisingly simple core concept? Well, today we're going to pull back the curtain and reveal the secret engine that's driving the entire AI revolution.
So, what is it? What's this one fundamental idea that's changing our world so dramatically? Honestly, it's not nearly as complicated as you might think. And once you see it, I promise you'll start seeing it absolutely everywhere.
All right, so here's our game plan. We'll start by pinpointing AI's real secret engine. Then we'll break down the simple A to B trick that makes it all tick. We're going to see it in action in spam filters, self-driving cars, and even in how things like ChatGPT predict the next word. And finally, we'll tackle the big one, why is this all exploding now? And we'll wrap up with the 2 keys to success.
Okay, let's get right to it. The term AI covers a ton of ground, but the recent explosion we've all been seeing, it's pretty much all thanks to one specific, incredibly powerful tool.
And that tool is machine learning. This is the workhorse. It's the engine that took AI from just a cool idea in a university lab to a practical technology that is completely reshaping entire industries. But what is machine learning really?
Well, at its core, machine learning really just comes down to a very simple trick. Now, the most common type has a bit of a fancy name, but the idea behind it, it's unbelievably straightforward. It's called supervised learning. And here's the big secret. All it does is learn how to map an input, let's call it A, to a simple output. We'll call that B. That's it. It just learns from tons of examples to figure out the connection between A and B.
And this right here is the key. Just look at how simple this is. You get an input A and you produce an output B. This one simple pattern, this A to B mapping, is the foundation for pretty much every major AI breakthrough you read about today.
Don't believe me? Okay, let's just look at a few examples. We're going to do a real quick tour to see how this one A to B idea powers a huge range of things, from the super mundane to the totally mind-blowing.
Let's start with a classic, the spam filter. Every time an email hits your inbox, that's your input, A. The AI scans it and produces a simple output, B. Either a 1 for spam or 0 for not spam. That's it. A simple A to B decision we all rely on every single day.
Or hey, think about talking to your phone. The input, A, is the sound of your voice. The system's job is to map that complex audio to the correct output, B, which is just the text transcript of what you said. See? It's another perfect A to B mapping.
And how about the most profitable application of all, online ads? The input, A, is a bunch of info about an ad and about you. The output, B, is a simple prediction. Are you going to click on it, yes or no? This incredibly profitable system is, you guessed it, just another A to B problem.
Now let's scale this up to something way more complex, a self-driving car. One of its most important jobs is to constantly take an input, A, an image from its camera, and spit out an output, B, the exact position of all the other cars on the road. It's a much harder problem, but the fundamental pattern is exactly the same. Okay, but what about the latest and greatest? What about these generative AI systems like ChatGPT? Surely they're doing something way more complicated, right? Well, not really.
So here's the thing. Even these massive, incredible models are built on the exact same foundation. They work by solving one simple A to B problem over and over and over again. Given a sequence of words, that's A, what is the single most likely next word? That's B.
And here's how it actually learns. A single sentence like, my favorite drink is lychee bubble tea, is broken down into a bunch of training examples. The AI learns that after the input A, my favorite drink, the best output B is the word is. Then, after my favorite drink is, the next word is lychee, and so on. It does this billions of times, and that's how it gets so incredibly good at that one simple task, predicting the next word.
But this brings up a huge question, doesn't it? The core idea of this supervised learning has been around for decades. So if it's so old and so simple, why is it completely taking over the world right now?
Well, AI pioneer Andrew Yu says that whenever people ask him this question, he draws them a picture to explain it. And now we're going to look at that exact same picture.
So this first chart, this shows how the older, traditional AI systems worked. You see, as you fed them more and more data, their performance got a little bit better, but then it just hit a wall. It plateaued. Even throwing massive amounts of new data at the problem barely moved the needle.
But here,
Here is the game changer. This chart shows modern AI systems. We're talking about the large neural networks that power today's AI. And just look at that jump. With these new models, the more data you feed them, the better and better and better they get. Performance doesn't just improve, it skyrockets. This is the aha moment. This is the reason it's all happening right now.
In that relationship, the one between tons of data and amazing performance, it basically reveals the entire recipe for success in modern AI. It turns out you just need 2 key ingredients to get to those incredible performance levels.
Yep, that graph pretty much gives away the whole secret recipe. It all comes down to 2 things.
So what are they? Well, the winning combination is this. First, you need absolutely massive amounts of data, what everyone calls big data. Thanks to the internet, we finally have enough text and images and audio to train on. And second, you need massive compute power. This means really, really large models, huge neural networks, and the super fast computer chips, like GPUs, that are powerful enough to handle it all. It's the combination of these 2 things at a massive scale that unlocked all the potential we're seeing today.
So that's really it. The secret isn't some kind of unknowable magic. It's just a simple A to B mapping, but scaled up with gigantic data and gigantic computing power. Now that you know the trick, it really just leaves one question. What A to B problem would you want to solve?